All right, welcome to the video on plate tectonics. I figured we'd start with this. This is the theory of continental drift, and you may recognize the shape of Pangea. If I click through the slides, you'll kind of see how we think the plates have moved. And there are fossil records that show similarities between the two different continents. And as we get closer and closer to modern day, right, these continents have spread out, those fossil records still exist, and so it allows us to piece these plates together. Now, how do they actually move? We have this layer of the Earth called the mantle, which is, relatively close to being a liquid. For our purposes, it's going to be a liquid, and the heat as it rises is going to drive these brittle plates across the surface, right? And when they come in contact with each other, certain things happen. That's kind of the important part for this section. So as it stands, this is a map of where the plates are at. And so these boundaries are where we're going to see these interactions happening, whether the plates are moving together or moving apart. Kind of varies on where you're looking, on the map. So let's get into the different types of boundaries that we could have. These are the big three. Divergent is when they move apart, convergence when they come together, and transform, they're just moving past one another. Let's get to some examples. Just showed that one. All right, so seafloor spreading. Seafloor spreading is a divergent type of plate boundary. Essentially what happens is the two plates underneath the ocean are moving apart. As they split apart, that liquid of the mantle is pushing its way to the surface, and it leaks out. As it comes out, we get new rocks forming. Right here is where we get the newest rocks forming, and so you can look at bands going away and see, and measure how much it's been spreading by over time based on how old those rocks are. But essentially, we're making new crust. Got that already. This is a good picture that kind of shows all of the different types of boundaries in action. So this is our seafloor spreading, the divergent boundary that we had on the last slide. Convergent can happen both under the ocean, like is over here with convergent, or it can happen between continental and oceanic crusts. And also our divergent can happen on continental. So this is kind of a good picture to kind of summarize everything. I want to get into some examples here. So this is another example of a divergent plate boundary. Here's an example of a divergent plate boundary. So if you need to pause and write down a couple of these for a response, feel free. I'm going to move, relatively quickly through them. This is a little animation showing what happens. And there's where we get our new rocks forming. Continental, very similar thing happens, right? It's being pulled apart, and as it gets pulled apart, you'll see convergent boundaries. So here's an example of a convergent continental boundary. So the Himalaya mountains are the tallest mountain peaks in the world. These are forming due to these two plates moving together. And so here's the animation playing above. You can see below, kind of the end result of these two pieces of crust coming together. And it's going to lift up and crumple that continental crust because the oceanic crust is going to be more dense, which is why it gets forced underneath. So the densities here is higher, which is why it's pushing below. This is a lower density, which is why it's above. And then as this one melts, that magma is going somewhere, and so it usually forms this volcanic ridge here. Oceanic crusts can also converge together. This can form these kind of oceanic island chains. A really good example of these would be Japan, right? Volcanic islands forming due to two oceanic crusts colliding together. Again, that magma has to go somewhere, and so it gets lifted up. Common misconception, this is not an example of how Hawaii formed. Hawaii is something different. We'll see in a minute when we get to it. Two regular old pieces of continental crust coming together can do the same thing. We see that lift coming up. And so hopefully you're starting to come together with some trends that when we have convergent boundaries, we're forming mountain chains, and we have divergent boundaries, we're forming kind of rift valleys. Transform is the last part. And so if you take a look, this red line signifies the San Andreas Fault. That plate over here is the Pacific plate, and this is the North American plate. So these are two separate plates. The Pacific plate is moving from the south to the north, and the Pacific, or the North American plate, then is moving down, and so that causes that shearing action between it, and so you can end up having roads. Can't tell if this is a road here or not, but you can end up having roads that are disjointed because the two plates are moving apart, or like a fence or something if you're like a cattle farmer on that fault line. Hotspots is how Hawaii formed. So hotspot is really just a spot in the mantle where it is unusually warm, warm enough to melt through the crust. And so as the plate moves over top of that hotspot, kind of this conveyor belt. So this would be the oldest mountain, which formed this island of Kauai. And as time went on, that moved off the hotspot. And so it sat here for a while and formed another mountain and so on and so forth. So it's a growing an island chain, essentially. I'm going to click all these questions out here. If you want to take a minute and pause the video and see if you can answer these, feel free. But I'm going to advance beyond. We're almost through our session. The normal fault is one of the possibilities for a divergent plate boundary. And so essentially what happens is as they separate, we end up with this kind of sudden crack formation. And this is where we can get earthquakes forming. Right? The earthquake can happen if these jump as they separate. But you can kind of create these kind of ridges from a divergent boundary. When we converge together, right, one of them gets forced underneath. This is the one that's going to go down and be melted into magma. The other one gets lifted up and forms this mountain range. You obviously wouldn't have something so sharp in nature. This is going to erode into kind of a rounded feature. Same thing, convergent. Strike slip, this is kind of showing what happens when we have that transform boundary. And so you can end up seeing some kind of strange things. I don't think these terms are going to be relatively important as we go through. Rift Valley, probably more so. This is via a divergent boundary on continental crusts. Just end with this picture of all of them. So this is the quick video on plate tectonics. Hopefully it's more of a review than anything, but as always, come into class with questions and I'll be happy to answer them.